Thanks for hosting this event, and thanks for inviting me to speak. I'm excited to see so many people out here coming to learn about this topic, because it's one that I'm passionate about. I love the API doc space. It's interesting. It's unlike nothing before. It's a difficult space to navigate, particularly when it comes to tools. And that's what we're going to be focusing on today. So here's a brief overview of what we'll talk about. What makes developer doc unique? We're going to look at some doc design patterns, some docs as code characteristics, markdown and version control, REST APIs and the open API spec, the jungle of publishing tools, and some lessons learned. So it's kind of cutting a broad path through this space, and I sort of realized in hindsight how much I was trying to tackle with this topic. So we'll see how it goes. If you want to find out more information, this is the Documenting APIs course that I have. If you go to I'dRatherBeWriting.com/learn-API-doc, I've got a whole section on publishing your API documentation. If you wanted to back up and start at the beginning, what is an API? What are the essential sections to document? That's covered in other parts of the course. This is the publishing aspect. We assume that you've written documentation, or you've got an API, and you've sort of made your way through the endpoints, and now you want to somehow present all this documentation to the world. How are you going to do that? So that's what I'm going to try to cover here. And all these different sections are my, if you go online and you read them, they're my attempt to kind of work through that path. And part of the appeal to present on this is that it helps me refine this. Presenting on a topic forces you to kind of figure out if you understand it or not in a more immediate way. All right, first let me clarify API docs versus developer docs, because I don't want to mislead you about what we're going to cover. All API docs are in the developer doc kind of domain, but not all developer docs have an API. A lot of them do, most of them do, which is why I just sort of titled this Publishing API Docs, because I assume you have some kind of API associated with all other kind of developer code frameworks and so forth. But when we look at API documentation specifically, people tend to gravitate towards the reference information. But it also contains a lot of non-reference content. The tools in this space are mind-boggling. There are so many tools. It's hard to even understand. It's a renaissance of tools in the developer space. For years, there was just JavaDoc and Doxygen, and they had a smattering of document generators that could build from the source. And in the last decade, there are hundreds, I'm not exaggerating, hundreds of tools for all kinds of different needs, code frameworks, platforms, and I'm going to try to navigate through that space later. And there is a huge gap in this area. We have API reference information, often generated from tools like, or specifications like the Open API, and we have non-reference, and the two don't always mix so well in terms of publishing tools. All right, so first question, why not just use traditional help authoring tools, or HATs, right? This is the first question you have to ask if you come from a traditional tech writing background and you perhaps have used other tools that are specialized for TechCom scenarios that handle single sourcing, multiple outputs, translation workflows, include search and content reuse. Why not just use all those tools? They've been evolving for the last 30 years or more. Well, here are some of the reasons why the developer doc space tends to not use traditional HATs as much. The primary reason is that we have developers as authors or contributors. And developers as authors want to use developer workflows and tools. This means they want to treat the docs like code. They want to manage it in Git. They want to read it in their IDE. They want to check it into their source control and build from the server. They want to manage it like code, and the traditional hats don't really have that sort of framework. If you try to take a binary file that's only computer readable and put it into source control and try to see diffs, it's not going to work. Another characteristic in this space is that you have APIs that have specific structure and templates. There's predictable sections to an API. You've got your parameters and your sample responses and your sample requests. And these templates need to be somehow formalized in the documentation. So that sort of element isn't so present in the hat world. Another major characteristic is that developers want to demo requests right on the page. Here's how you make a call. Click the button and try it out, and you can see, in real time, the request happening. And finally, in API documentation worlds, the product, there's no GUI usually that people navigate to learn about your code. They look at the docs as kind of the product interface. And as such, there's a lot more attention, more pressure for that product interface, which is the docs, to look better, to sell. And if you have kind of this old tri-pane sort of look that kind of echoes from the 90s, it doesn't really go over so well. So that's sort of the reasons why traditional hats tend to not play so prominently in this space. Now, because of that, there are serious challenges that are hard to overcome. And I'll get into those a little bit later. Chuck.
Are you taking questions?
Yeah. Throw up questions.
I'm inferring from what you're doing, this has to do a lot with open web APIs. For APIs for libraries in more closed systems, where you have closed systems talk to each other, but you require APIs and API docs for those systems, do people who are reading those types of documentations do the same interaction with that content?
Yeah, so actually you bring up a good point that I didn't clarify. What do I even mean by API, right? Because you've got Java library APIs or other library-based APIs that aren't web-based APIs. I'm mainly talking about web-based APIs here. Traditionally, the Java APIs are still documented with JavaDoc. It's just kind of how it's done. So yeah, when I talk about APIs, just assume I'm mostly referring to web APIs. There's other types of APIs, right? People talk about Android as like APIs for every method. So that's sort of a different ball of wax. All right, so I want to begin somewhat descriptively. And all right, we'll see how this works. Instead of just coming out and saying, hey, these are the characteristics of developer doc sites, I want you to, you know what? I didn't realize this. No, everybody doesn't have a computer. Okay. You know what? You could do this later. We won't do this now. I sort of structured this content as a workshop, right? And what I usually do is have people kind of click around on a list of 100 different APIs, find 3, and try to identify what are the common characteristics that these show. And if you were to sort of identify commonalities across lots of different API doc sites, you would see some of these design patterns. They have very defined structure and templates. I already mentioned this, right? When you've got the API reference content, it follows a specific order. And that is the core characteristic that all API docs share in the web API space. They're usually delivered on a website platform. Hand in the back, yeah.
Could you load just one of the 100 and show some of those bullets on it?
Yeah, we'll see. Do you want me to load one? Okay, we're going to try that. All right, so does it really look that small on here? Let me try some. All right, well, so let's look at, how about this one, Box API Docs. All right. So one of the characteristics is that they have these common. This is kind of an obvious point, but oops, I didn't actually mean to go to that one. Let me back up. Go to the which one?
No. I'm saying.
Okay. So they've got these common sections in an API. You've got a curl example. You've got, and you know what? I'm probably not finding a good one here. But basically, if you were to look at, the API reference part, you would see very common sections. It's gonna start out with a description, followed by here are the parameters, followed by here's a sample request, and here's a sample response, and here's a description of that response. You'll also notice that it's on a website platform, right? It looks like a website. It doesn't look like a little standalone microsite with TriPay and help. The pages tend to be long. This one sort of defies the standard, but by and large, the pages in developer docs are long. Developers, they don't like to click around. They kind of like the single page model almost. So you'll see a lot of APIs where all the endpoints are on the same page, and with sophisticated navigation, you can jump down to the one you want. Let me jump back here, see what other characteristics. API interactivity. I'll show this a little bit later, but the interactivity I'm talking about is the tried out feature with requests, where you can kick off a request right there and see the result. Okay, sorry, that was a strong ask for me to pick one of those sites that would demonstrate all 5. But trust me, you see this. Abundant code samples is another. They literally have lots of code samples. They're structured in a way that they have syntax highlighting. They're formatted in a readable way. They're all over the place. So you see that as a common pattern. All right. Now I'm just talking about general characteristics in this space. Developers like to treat docs as code.
Are you send those slides over later? Or?
Oh, you can just go online at i'dratherbewriting.com/publishing-api-docs. Yeah, and I'll post it. I'll put a post with the link. But yeah, and the recording will be available too. What does it mean to treat docs like code? This is a topic that's sort of been written about a lot, so I'm assuming most people are familiar. But if not, it kind of has these characteristics. You write in a format such as Markdown, restructured text, something that's human readable, even in the shape of code. You don't have a bunch of markup tags that are making it difficult to read in a regular IDE-like text editor, right? You want to open up in something like Atom, or maybe they're using one of the IDEA IDEs. A lot of times they use static site generators to build the documentation. We'll jump into that later. Exactly what is a static site generator? It kind of loops, it compiles your code and generates out a website. It can run different processes to package content into layouts. It can run scripts. It can do other kind of fancy stuff, and then gives you a website that you deploy. They use Git to manage their content. So if you have 30 people working on a doc solution, you've got it's the same Git workflows with branching, merging, and pulling, and pushing, and forking, and all that stuff. This is something I'm going to jump into a little bit more in a minute, but the Git side can even be more complex than the static site generator. And finally, building from the server is another common characteristic of docs as code. There's actually a whole book that Ann Gentle wrote on this, on docs as code, so check it out if you're interested in diving more. But that's kind of the basic characteristic that a lot of these sites follow. Joe?
Can you elaborate on what you mean by build from server?
Yeah, we'll jump into that more. It basically means you commit your code to the repository, your Git repository, and there's a listener in that repository that says, oh, it's time for me to build the site and push the files out to whatever deployment location there is. So you no longer have to upload files. I think this is one of the key features I'm going to dive into more, so I'll save some more comments on that in a minute. Markdown Oh, yes,
One
sure.
more question.
Yeah.
So, does that work with SVN as well as Git, or just Git?
Oh, yeah. No, it works with SVN. I just say Git to be more like immediate and concrete about a version control. It could be Mercurial, Git, and probably others that people might use. All right. Okay. Markdown is often the preferred syntax that people use with these tools. Could be restructured text as well, but Markdown is really more common. And the reason is that it's readable as code. You don't have to buy an XML editor in order to kind of render the content readable at a glance. It can be used with any sort of editor that you use. A lot of people use Atom. And I mentioned earlier that this format is compatible with version control. You really couldn't use a Word document, for example, check it into a Git repository, and manage it that way. The binary files just don't work. So this excludes a lot of other stuff, but it sort of defines what they are going to use for their tools. A lot of people say, you know, why are you going to write in Markdown? This is the biggest question that I hear from tech writers moving into this space is, well, I couldn't do everything I need to do in Markdown. I have complex reuse. I've got, you know, a lot of semantics tied into this. Markdown is way too primitive. It's not going to work. Well, usually, a developer has, or an author has a static site generator that has scripting language in it that can do more complex tasks. If you wanted to kind of loop through all documents, get a certain property, push it here, you know, sort and filter, use a variable, reuse snippets, you would do that through whatever scripting language is available in your tool. Now that's problematic because then you become more kind of married to that tool, and it's harder to port, which is why a lot of people say you shouldn't use Markdown. It's too non-standard. Even without the scripting, you've got multi-markdown and cram down and GitHub flavored markdown and original markdown and other markdown, and like you start writing in that way, and then one day you think, I'm going to use another tool, and suddenly you realize that you have to like adjust all your content. So
it's also implementation specific. So as you move to another company, you've got to learn a new way of doing it.
yeah. By and large, I think 80% of the Markdown syntax that people use is the same. It just varies in some smallish ways. If people want to define some content semantically, by this I mean, let's say you have an intro blurb and you want to somehow mark it off as like, hey, this is my intro blurb summary, right? Markdown doesn't offer semantic tags. So what developers often do is they define that in some front matter at the top of a Markdown document that is often in YAML, which stands for YAML ain't no markup language. So it's basically it's a syntax that is space sensitive with no angle brackets or markup tags. All right, so there's huge debates about Markdown, especially among like Markdown versus RST, restructured text, or Markdown versus XML, and it's one of these sensitive issues. But by and large, if you have developers who want to contribute and author, they're not going to write in XML. They're not going to write in DITA, and the tools that are being developed for all these scenarios, they're using Markdown or some other lightweight syntax. So you have to figure out exactly how to make that work for you. All right, another big component of this developer doc experience is using Git. And it's sort of underestimated how revolutionary Git is. It really is an ingenious way to collaborate. When you move away from traditional models of collaboration where you might have checked a file into SharePoint and out, or use some other kind of syncing to Dropbox or something, Git gives you lots of power to branch and make content unique to a certain feature and then merge it in, or to merge other content in. It just works. And once you get used to it, you might think, how did I ever live without this? I really think it's one of the key selling points of moving into the developer doc landscape. It also gives you an inside view of how the developer's mind and workflow kind of works. When you understand the Git branching, you can look at their code repositories and say, oh, let me see what was committed, and let me compare the two different files, and let me do a branch, and I'll put my docs in here, and I'll submit a pull request, and they'll merge it in. You can implement workflows, and you can work better with engineers when you understand how they work. Finally, the Git model really scales. You don't have to give another contributor a license for a seat into software so that they can then contribute into your private proprietary repository. They just, you give them access, and they can be a contributor. They can submit a pull request. It works really well. Okay, building from the server is another very common characteristic, and this feature is often called continuous delivery. If you've ever had to upload your files to a web server, you know what a pain this is, right? You build your content, you've got your HTML files, now you FTP them or you upload them somehow, and it's a pain. With continuous delivery, all you do is you commit your updates in Git or whatever version control you have, and there's a little listener sitting in the repository that says, oh, somebody just made a change in the production branch. Now I'm going to initiate a publishing pipeline to kick off a build from the server. So if I have, for example, Jekyll, there's kind of like Jekyll installed on the server, and it builds it from there. And then usually there's like what do we do with the built files? We push them onto some web host location. Removes a ton of work from uploading content. It allows you to focus on writing, and you can just make updates and not have to worry about how long the build is taking or other processes. And this, I think this is really the killer feature that looking back, if I had to pick one thing that stands out as the best, it's continuous delivery. All right, and finally, API reference content is very common in these. A lot of times you will describe your API using something called an Open API specification, which is just a standard way of describing the various elements in it. I won't dive too far into that, but it is the way that a lot of people document the reference part of an API. If you think about how many different ways somebody could describe the elements in an API, a parameter. Well, you've got a header parameter, a body request parameter, you've got query string parameters, and people might have like 10 different ways of naming this, and some people may omit whether it's required or not. When you use this Open API specification, it sort of walks you through what the terminology is, how it should be structured. You can't just omit some things that are essential. And so this introduces another complexity in the tool landscape about, now that I've described my API with the Open API, how do I read and parse this spec document and integrate it into the rest of my documents, my documentation. And I'll talk more about that later. Okay, so let me pause here for a minute. Went through a lot of different stuff. I was kind of just giving you a high-level overview of what makes this space unique, what are the core characteristics. Questions, comments that you want me to jump more into? Yes?
One quick comment I have is that with regard to the lengthy pages and reference docs, given how much more time people spend on mobile devices, they're a little bit more used to just kind of this passive clicking. So scrolling isn't quite as time-consuming process for even the effort.
Yeah. Oh, good point. Yeah, thanks. So just basically saying that our mobile devices have trained us to scroll. Joe?
I'd also say that developers are probably more used to scrolling through a very large piece of code, so they don't mind having to read through a whole bunch of stuff or skipping around among things to be able to stuff. But I was going to also point out that continuous delivery is also what developers use to build their own products. I mean, they use continuous delivery to build, test, and make something available. So first of all, they'll be used to it, and second of all, you can piggyback on their efforts to be able to publish your docs.
Good points, good points. On the page link thing, interesting side note. I recently analyzed metrics from my site to see what the most popular posts were, most popular pages. The average is 1,600 words. I counted all the words, and it aligns with a lot of arguments for long-form content. If you Google what's the ideal length of a post or page, it's like 1,600 plus. People really like long content because they feel that it gives more value, and because it gives more value, they're more likely to share it and promote it and link to it. And when you share, promote, and link to it, it surfaces higher in Google's results, so it kind of feeds on its own visibility cycle. But yeah, it's in sharp contrast to other information models that would chunk everything out into like, oh, this is just one little task. It's going to be its own topic because we want people only want to see the information that relates to them, and so we're not going to put anything else on the page. That model doesn't really align with content science or analytics. All right, so now we're going to jump into the really difficult part, and this is where I started. As I was trying to sort through things, I was like, man, this space is so complicated. All right, so authoring and publishing tools. Oh, where's my little clicker? Let me see what happened here. Oh, there we go. This is my attempt to do an Aristotelian classification on the vast sort of landscape. There are 4 categories of tools. There's static site generators, hosting and deployment options, headless content management systems. Thank you to Jessica for that. Tools to render open API specs. Okay, and again, I'm not diving too deep into how you create that spec, but assuming that you have one that you've used to describe your API, how do you render that into documentation? All right, so let's jump into the first one, static site generators. Common ones are Jekyll, Hugo, Sphinx, and about 350 more. But even though there are so many, I mean, there's one called Frog, there's like tons of others. They're only probably the top 10 are ones you would normally see. Jekyll is the most popular, but in part that's because it's been around probably the longest, or one of the longest. Started out with Tom Preston Werner, one of the co-founders of GitHub. He was using a content management system, and he said, you know what, I hate this clunky thing it's got all these different components and plugins, and it's way too complex. All I need is something much more lightweight, and I'm a developer, so I'm going to create my own tool. And he created Jekyll as one of the first sort of static site generators that would implement this new building and publishing process for a website that would largely replace the content management option. So here's a little bit about how static site generators differ from the other tools. If you have used WordPress, which is like powering a third of the internet, you log in to an interface, and when you type and save content, it gets saved in a database, and when you publish that page, the content stays in the database. When a user goes to a page, there are calls that say, oh, hey, let me go get this content from the database, grab it, pull it, and dynamically insert it into the page. Static site generators say, that is such a waste of time. Why don't we just build all the content in the page right then? We'll put all the content in there, build the whole HTML page. When a user comes to it, it's there. So it speeds it up a lot. Usually the pages load, of course it depends on how you coded your theme, but they load in half a second versus like 2+ seconds with the CMS. A lot of people just got tired of these bloated CMSs that tried to do everything, that were just getting larger and larger. And the static site generators pretty much don't have a database backend. The files are flat files. They're stored in a version control repository, and it's a much lighter weight solution. Now, Jekyll is probably one of the oldest, but Hugo is kind of gaining in popularity because it's much, much faster. Jekyll is built on, or it's based on Ruby. Hugo is based on Go, or Golang, which is a programming language invented by somebody at Google. And it's fast. If you have a Jekyll site with 3,000 pages, it might take you 5 minutes to build it, or less. I have about 2,500 pages on my blog, which is built with Jekyll, and it takes about 4 minutes to build. Of course, a lot of that build happens on the server, so I never really see. I never really care. I check back in a few minutes. But Hugo can build that same site in like half a second. So it's much more efficient, and that decision becomes much more important when you start to think about your content architecture. Let's say you have 20 different products. Are they going to live in one big repo or lots of little different repos? Chances are they'll live in one big repo because of all the other work to hook that into a publishing pipeline. And if you've got those thousands of pages, you want it to build fast. So speed, in terms of like how fast the site compiles and builds, is a huge characteristic. But since you build from the server, not a deal breaker. And there are workarounds to get around that. Now, Sphinx is also a super popular tool. But if you look at staticgen.com, which indexes all these hundreds of static site generators, you'll find that Sphinx is like 20 down. You see Jekyll, most popular, Hugo, second most popular, Gatsby, and like Wintersmith, and all these others, and then you finally get to Sphinx, and then you get to a lot more. But Sphinx is primarily designed as a documentation tool. So it's got features built into it that you will be thankful for. It's got search built into it. You can generate a PDF or EPUB. It's got RST, or restructured text, that allows you to implement more semantics. Like, let's say you wanted a warning, right? In Markdown, there's no warning element. You can do that in Sphinx. It was designed to document the Python programming language, so it's based on Python, and you can, it's got some features to document Python classes if you want. But because it's based on Python, that programming language tends to be really helpful when you're writing your own scripts to do validation checking or something else. So it's very popular, and we'll see later that it plugs directly into Read the Docs, which can be helpful. Okay, questions, comments? Static site generators. All right, let's jump into category number 2 in the tool space. Hosting and deployment options. So there's not really a good term to describe this category of tools. It's not just web hosting. You can get web hosting from Bluehost for $3 a month. That's not what we're talking about. We're talking about platforms that have been developed to integrate with static site generators to take your commits to a repository and build your output, deploy it, give you like SSL or minification or authentication or CDNs and other kind of fancy stuff, and scale it in a much more efficient way. Here are some common ones. There are lots. GitHub Pages, built right into GitHub, allows you to, it will build your Jekyll site. So if you've got, let's say you're working on your open source project in GitHub, and you've got your docs in a Jekyll project, well, you just go into the settings in your GitHub repository, say, yeah, this is a Jekyll site, build it, you check it in, and it's going to automatically build it, and you're done. This is how I have my site set up, my blog and my API doc site, because it's super easy. And it integrates into GitHub if you're already using it. It's kind of a nice complement. Some others, one is called Cloud Canon. This one specializes in Jekyll sites, and it's got a lot of features that are relevant to documentation, like authentication. You want to password protect your content. That's actually quite a difficult thing. Or if you want to, won't go into all the other details, but basically, it's robust and built around Jekyll. Now, with these solutions, you're not necessarily uploading your content into their platform. You're just pointing to a GitHub repository or a Bitbucket repository, and it's reading your content there. So it's kind of an interesting thing. It's sort of this interface that sits on the web, but your content lives in GitHub, and it's just kind of, it will pull it in every time you push to it. So it seems like it's there, but it's not. Read the docs. This is, if you know the history of Write the Docs, started by Eric Holscher, he saw that there was this need to help people publish their content, especially developers. And there wasn't a lot of tooling. So he started to work on the solution that would auto-build Sphinx projects from the server. And in this platform, Read the Docs, there's a commercial version and a free version, .org and .com. And it is the largest open source doc project site in the world. It's got like 50,000 projects. It's got millions of page views. I didn't realize this until I was looking into his metrics. So it's super popular. And if you have a Sphinx static site generator, it integrates nicely into that. You don't have to write in restructured text. You can write in Markdown, but then you kind of miss out on some of the semantic features. But it's a cool platform, and it's kind of nice that it provides the free model, and then if you want to ramp up more of the commercial tools. Netlify is another one. This one is, we've got Jessica here who works there, and this is a cool platform because it doesn't say we're only going to process Jekyll or we're only going to work with Sphinx. No, you work with any static site generator. And it adds all of these hosting and deployment features that you want to build from the server with continuous deployment, and it will push your site out to lots of different places with the content delivery network model, so it delivers it faster, and other features. Aerobatic is another one. Now, I've only used GitHub Pages, to be honest. I've tinkered around with some of the others, so I don't know all the details, but these are the main ones in this category. Yes?
So what would be the reason maybe to, or not to use just Apache Web Host and throw those static systems off?
So the reason you wouldn't just want a regular web host is because you want something that's going to build your project from the server, basically. I mean, they do more than that, but this is the core value I see, is that it's going to build it. Maybe you could build out logic into Apache Web Host if you've got engineering resources and talent, but it tends to be more of an engineer job. Yeah, and there's lots of other options in the back.
Is it fair to describe these hosting and deployment options as static generation as a service? Because they're hosting the Jekyll for you.
Should you call it static generation as a service?
Because it sounds like they're just hosting Jekyll for you, they're hosting the Sphinx.
Well, the problem with the naming is that by committing to something like that, they sort of limit what the platform does, so they want to keep it broad and vague. Maybe there's a better term. Jessica was saying that there's been lots of discussions. What exactly do you name it?
Everything to everybody.
Yeah. Phil.
A lot of these services and solutions seem to be outward-facing open source. Would any of these be appropriate, or do they have solutions for inward-facing proprietary APIs, or maybe a hybrid model of proprietary API that you might want to expose sections of?
That actually brings up a huge problem with these models. No. Your question, how do you handle private proprietary content? In a lot of these situations, a lot of our workflow is that we work on doc that hasn't been released, right? Because the feature hasn't been released. You can't just keep that content in a public repository and be like, oh, nobody's going to find this. So what usually happens is that, well, I'm sure some of these platforms can read private repos, I'm sure. And that's probably the reason to use some of these instead of the default GitHub Pages, which I'm not sure if it reads a private repo or not. Yeah, maybe they do. But some of these others would offer more authentication and authorization and stuff, and that's why you would scale up to them. But even so, you sort of, by naming a source for your content outside of your company, that can be a rough road to get permission for. So a lot of times companies build their own thing internally, and I'll jump more into that later. Yeah.
Part of what you can do, though, is you can roll out stuff from development into production through GitHub. Well, not through using GitHub, but through using Git. In other words, you can keep everything private within your own local repositories until you're ready.
Yeah, keep it in a private branch. Hope that you don't drop your computer. just kidding. You got it. No, yeah, and this is where the Git workflows. Yeah. Yeah, and add a remote, and I struggled with this trying to define the workflow. I wanted to keep all my docs in an internal Git, and when publishing them, put them in an external repo. But every time I did that, there were some internal config files that would get pushed there, and I'd get pinged by security, and they say, "Take those out," and I was like, "How do I do this?" So I gave up. Anyway, all right. Third category: the headless CMS. What do I mean by headless? So remember what we said about content management systems that had this database layer, and you log into your WordPress site, and it's got kind of the GUI where you write your post right there. Well, a headless CMS is sort of like this client-side, just in the browser interface that's not necessarily tightly coupled with that database and this heavy backend. It sort of communicates with a database through an API, so it's decoupled and that head is sort of severed. At least that's how I understand it. At any rate, Forestry, Netlify CMS, maybe README.io, I'm actually not sure. They're not your traditional CMS because they're not going to store. Well, okay, I probably shouldn't have put README.io there because I'm really not sure if it qualifies. But with these others, you store your content in a Git repository. It reads it, but it gives you a nice interface to it. If you don't want to work in your text editor and have that kind of techie code view, this gives you kind of that same experience like a content management system where you can browse visually. With the Netlify CMS, they sort of wrap around almost any static site generator you have, and you can, and this is an important point, let's say you have that intro blurb field, you don't want to rely on your authors to always write the intro blurb in a consistent way in the front matter. Maybe they capitalize it or camel case it, and then it screws everything up. You can map different fields to kind of forms in your CMS and provide more of a standard way to approach it. By and large, though, I think the CMS interface is to try to make the experience much more authorable for non-technical users. When I'm writing just a blog post, regularly people who look over my shoulder, whether it's my kids, somebody in the airplane, they're like, "Whoa, are you programming?" Some guy in the airplane was like, "Wow, I've never seen anybody program in real time." I'm like, "Dude, I'm writing a blog post in Markdown." It was crazy. So it can be kind of intimidating, and this abstracts that complexity away.
You don't use a Markdown editor?
No.
Markdown editor?
No. I mean, that's the point of Markdown, is that you shouldn't need an editor. It should just be visible, human readable in the code. So the reason I called out these headless CMS categories because it's usually on a platform that sort of does both the static site generator and the deployment in one. And that's what the README.io tool does. You don't have like this static site generator on your local machine and some host and deployment service. It does the same thing, all in a web-based interface. Fourth category of tools, the open tools to render the open API spec. And here's where I would probably jump into lots of demos. As you can see, I sort of planned, but looking at, we got like 12 minutes, and I think this is going to get difficult. So I'll just talk through some of these. Let me just start off real quick. Have you heard of the Open API specification? Raise your hands. All right, have you heard of Swagger? All right, so like most of the people are familiar with this. When you describe your API, you often follow this Open API standard. It's think of it like DITA. DITA has a specific schema that it uses to describe help content with tags that have certain names and certain hierarchy and order. And when you do that, tools can read it and parse it and create cool documentation, right? That's kind of like half the reason to even use DITA. Well, in the API doc world, we have a similar schema to describe the different components of the APIs, and it's called the Open API specification. And when you write to that, it's in a predictable way that programmers can parse and do cool things with. So you have a whole different category of tools that are specifically designed to read the Open API spec or other specs. There's one called RAML, there's one called API Blueprint, and create interactive documentation. Interactive meaning lots of tried out features. So you make a request, type in your parameter, see what response you get back. The free one is called Swagger UI. It's an open source GitHub project, and you basically just download it. You change the default Swagger or default Open API spec file to your own. You open it in a browser, and voila, it looks cool. The sample pet store one shows collapsible sections, and you can open it up. They have a commercial version. So all of these, when you talk about Swagger, it usually refers to tooling. They've sort of tried to change how these terms are used. The commercial version of Swagger UI is called Swagger Hub. Because let's say that you think, oh, this is neat. You've got this tool that can read the spec, but now I want to collaborate with the developer, and I want to make some inline comments, and I want to have multiple versions, and I want to have it shared and hosted. Well, that's where the commercial version comes in, and Swagger Hub does that. I mean, if you think about it, when you're writing documentation, you really want to collaborate with engineers. You want to have a way for them to comment. You don't want to just say, here, engineers, you annotate your source code and you can write the docs. No, you want to have control, and this gives you that collaborative sort of element. README.io is probably one of the most interesting tools. It allows you to import an Open API spec. So you can create your normal documentation using simple tools to create new pages and add titles and code blocks and stuff. But then you can just upload your Open API spec, and it will kind of populate the site with that for your reference docs, but your other docs can mix in. If you don't have the Open API spec, it also gives you forms to just sort of fill out. What's your parameters? What's the endpoint name? And it will format it. When I look back at all the time that I've spent kind of tinkering with tools and trying to set up my theme and figure out the way to parse through different things, I think a solution like README would be really time efficient. People kind of underestimate the amount of time you can sink into these tools. Another one is called Spectacle. This is another project somebody made that will just read your API content. We'll show it in the 3-column pane, which Stripe made famous. Stoplight.io is a new one that I wasn't that familiar with before, but they're similar to README.io. They will read your Open API spec. But what's cool about Stoplight is that rather than just uploading your Open API spec, it gives you an easy interface to create it. You click Add Parameter, and it pops up with a little modal that lets you populate the parameter, and then it builds out this specification. Because, trust me, creating a valid Open API specification is not a trivial task if you have a complex API, and it requires quite a bit of ramp-up time. So there's quite a few tools actually that are trying to simplify this process of building the spec. And at first, maybe that was their goal. They're like, we're going to make it easy. We're going to give visual controls to build it. But now they've evolved and said, well, let's also host their docs, and let's host their non-reference docs. So with Stoplight, you can combine the reference and non-reference. A couple of others. API-Matic is quite a impressive tool. Lets you convert basically any spec to another spec. If you have Swagger 2.0, you want to convert it to RAML and back, but they also host documentation, and they have a unique way of doing it. And then Restlet Studio is another one. So there's probably a dozen more of these. A lot of these platforms want to manage the whole like API lifecycle. You're going to design your API here. You're going to test it. You're going to write your specification file. You're going to do other kind of mock servers and stuff. And it's got this whole like platform for it. And there's lots of these. Yeah.
How is Redoc?
How is Redoc?
Redoc.
Ah,
Heard of it?
I'm trying to remember exactly. I don't know all the details. Is that a static site generator or what?
When a Swagger specification has
Oh, okay.
inheritance and polymorphism, like
Okay.
discriminator.
I'm not that familiar with Redoc. That would be a good one to add to this list. So thanks. I'll check it out. How do you spell it?
REDOC.
Okay, REDOC. All right, so integration challenges. This is the biggest gap right now. You've got your reference docs, often auto-generated from the Open API, and then you've got your non-reference docs, and trying to combine them is really difficult. If you've got a static site generator like Jekyll, Hugo, Sphinx, you don't have a lot of options to just take that output from the Open API, the generated doc, and put it in there. You can embed it, and it kind of works, but it looks like a site embedded in another site. But some of these platforms that I mentioned, README, Stoplight, they're starting to integrate, but then you've got third-party services. It's not just an internal solution. So generally, I think what most people do is they have their non-reference tutorials, conceptual content in one site, and they link out to the reference, which follows the pattern that has been around since JavaDoc, where you have a separate output for your reference documentation. So developers aren't up in arms. It's like, why don't I have one seamless site where everything just fits perfectly together in a branded, cohesive way? That's more the business side. Okay, so which tool? I only have 4 minutes left, but which tool should you use? I actually have a page on my site that tries to guide you through this process. But you start out by trying to define your requirements, which sounds simple until you want the whole world. And you're like, oh, of course I want PDF. Of course I want translation. Of course I want great search. Of course I want this. It's like, well, you're not going to get all that. Choose your priorities. Is PDF really important, or is like a customizable web more important, or is it more important that you don't have to do the code part with the theme? Do you want the control? Do you not want the control? Consider the amount of time you're going to spend. Do you want to spend a quarter of your time on tools? Because if you're the tools person and you're in charge of this workflow, that's at least how much time you will spend. Especially if you start to customize your own theme, and then you're responsible for other feature requests, and you have bugs and issues. You suddenly have to sink time into learning CSS and HTML and JavaScript in more advanced ways. And then hope that after this implementation, maybe you've got custom build scripts on the server that run with a certain tool. Hopefully you chose something well, because it's really hard to undo. Once you've got custom scripts and processes, it's not easy to just jump onto another solution. All right, in this last section, I'm going to go over some lessons learned. And it looks more negative than it is, really. My current setup, this is what we implemented in my Amazon Doc group, which is we focus on the App Store. We have a Jekyll, and this is mostly because I wanted Jekyll and was familiar with it, right? We have a Jekyll theme, but it doesn't have a header or footer because we want to we want it to be seamlessly branded with the other parts of the site. We have an internal Git infrastructure because, again, we have a lot of internal content. Can't be out in the open before features released. We had the engineering team that supports the site build out a publishing pipeline that piggybacks on the existing workflow infrastructure. As Joe said, developers have build pipelines. They have continuous deployment kind of an infrastructure for doing that, and they just sort of plugged in with the same. Now here they had a complexity where they wanted to take and build the site and then pull the HTML into AWS S3 and then match server requests with those keys and dynamically insert it into the template that would have the header and footer. And it actually works great. It looks good. I always thought that it was way more complex than it needed to be. But when you have engineers build systems for you internally, they probably look like this, kind of like, whoa, why are we doing all this? But the engineers, they understand the infrastructure, they understand the workflow. They probably don't understand the static site generator component as well, but they know how to kind of navigate through the internal processes. So if you're forced in the internal, you can't use an external host to do your deployment and all that. That's what you might end up with, a solution that seems more complex. Overall, my experience in switching to this model, I mostly love it. I would not go back. I think that continuous deployment is the killer feature, as well as managing content with Git. I love the control, the flexibility to do whatever I want with my static site generator. I recently added like some navigation maps, and I love the ability to just do that. It does take a lot more time than one would expect, and there's still some pain points with search, translation, PDF. They're not easy to solve. I end up with hacky workarounds. I'm going to skip this part. This is my last slide here. This is sort of what I know. It's a confusing landscape. There are a lot of different tools and categories of tools and processes, but here's what I sort of have settled on as, yes, I'm confident I can say this. I think it's a good practice to describe your REST APIs, and you document them, using the OpenAPI specification. It's just crazy to me that people would just decide whatever way they want to do it. We need standards around that so that we can have predictable and interactive documentation from it. Building continuously from the server is definitely something you want to have in there. It will make your life much easier, much simpler. You can focus on the content. Managing content with Git, another huge benefit. The more you work with it, you learn the Git commands that you need to know, and it can make your life simple. If you can use third-party solutions, do it, because you don't want to spend all your time learning the ins and outs of some tool and trying to build your own pipeline and so forth. You can spend an infinity in the rabbit hole of tools, and you generally just have to weigh the trade-off. Is it really important to have control and flexibility to customize my solution to exactly what I want, or would I rather just kind of offload that to a third party and accept that I'm not going to have as much control, but I won't have the responsibility for maintaining a server and making sure the code doesn't have bugs and just sort of making the experience viable and workable. It's a trade-off. If you go with a solution like README, you're going to complain that, it doesn't do this certain thing. But then you don't have to maintain the server and the build workflow either. All right. That is the end of presentation here. Questions? I'll give people a couple minutes for questions, and then I'll take questions afterwards. But any topics or feedback or comments you want to chime in on? Yeah. Wait, behind you. Sorry.
Yeah, so I've just finished going through your API course on your website. Thank you. It's very detailed. Excellent body of information. And so I understand that you can use, CodeGen to generate the OpenAPI spec from the API itself, from the server side, or you as a writer can write the OpenAPI and have the developers implement that and have that as a contract. I kind of want to do that, but I also want to know if there's an automatic way that if changes happen on the actual implementation, it would notify, like if a new API is added, a new endpoint is added. Is there some kind of scheme?
Okay, so you're saying, there's two ways to generate that specification document. People can annotate the code with special annotations, use this CodeGen library, and it renders out the spec that then you can feed into these other tools. And the main argument there is reduced documentation drift, right? We can hopefully not have parameters we missed and so forth. Is there any way to auto-notify when you manually create it? I don't think so. Maybe, but I don't know of any way. The trend now is to manually create it, actually. Even though a lot of developers don't want to do that, maybe they're the primary authors and they work on the code all day and it makes sense. But for tech writers, you may not have access to the code, or you may not, maybe your developers don't speak English very well and they don't even really want to be in the business of kind of maintaining that. So the current best practice is to use the spec document as a blueprint, as a contract that developers have to write to. Whether they do or not, there's nothing to enforce that. There's nothing to kind of do a two-way communication sync between the two that I know. But maybe it's available on one of these platforms, one of these more comprehensive, platforms that manages the whole life cycle, perhaps. I'm not really sure. All right. Yes.
One of the things that I've noticed is, when you create these code samples, the request example and the response examples, the JSON files can be like very huge, and it could be very nested. So what's your recommendation of, how to document, parameters?
How do you document the JSON response? That is a great question, because you're absolutely right. Like, yeah, you could have multiple levels of nesting, repeated elements, and how do you do that? The standard approach is, I'm just going to do a table, and I'll just define them here and there, and then you're like, oh, maybe I'll do an extra row for the nested part, and then I've got another nested. Wait, I already repeated this. So different people have approached it in different ways. Some people, the proper way to do it, in my opinion, is to describe it using the OpenAPI specification syntax. And that will feed into the JSON schema. The OpenAPI doesn't try to tell you how to describe all the JSON because it's already documented in something called JSON schema. So if you describe it there, then when you do, let me just give an example of this really quick. Oh, my timer telling me to stretch. When you do, when you document it using the specification, maybe I'll just come back to that. Then Swagger UI, or whatever tool you have, is going to describe each of those, each of the responses in a cool way. Currently, the Swagger UI will give you kind of like a sample response value, and below that it will describe that value. So you can see it in the exact structure. And yeah, let me just go to that real quick if I can figure out. There we go. Okay, Swagger UI demo. Oh, okay. So here I've actually embedded the Swagger UI output right in my page. And it looks like a website embedded in a website, right? But it's got all the functionality here. You expand it, you try it out, and so forth. You can do requests. But here, this part that's actually going to describe the response sort of doesn't fit in there. You'd have to override it with CSS. It turns out to be more complicated than it looks. So most people just have it as a standalone file. And here, the liquid layout works a lot better. But if this get weather data, okay, so this is, don't worry about this model section. I don't know why they put it in there. Get weather data has a response that's huge. See this example value? It's got a lot of nesting, and it's kind of like the sort of sample response that's sort of beastly. They let you switch into the model, as they call it. And, oops. Oh, man. I screwed something up. Sorry. Oh, that was unclimactic. Okay, well, I think they have it down here. It's going to look like this, where you've got each element described. You've got an example, and then the definition. So it's sort of, ideally, I would have shown it. It would show the same structure as the response. It would look like this. So that's one way, and I wouldn't try to rack your brain trying to figure out a creative format to do that. Just describe it with the spec and let the Swagger UI tools display it like they do, and people will figure it out. Or you could do a custom thing. It's just all right. Any other questions? We're kind of at the end, so let me just remind you where you can find more information. You go to my site. I'd rather be writing.com. I've got an API doc link right there, and this is where the course is, and the publishing API section we went over is right here. You can sort of dive more deeply into that. So thank you.